Welcome to my presentation. My name is Madeline and I'm currently working at the Fraunhofer IOSB. Today I will present our concept to continuously monitor surface deformation employing persistent scattering interferometry. So why do we want to monitor the surface deformation of a particular area permanently? Well, critical infrastructure such as dams or bridges need to be monitored closely in order to ensure their structural stability. Persistent scattering interferometry can be used to do this. However, instead of one deformation map covering a certain observation period, we need regularly updated deformation maps in order to identify accelerating or decelerating deformation patterns, as well as short-term deformation patterns and seasonal effects. Instead of processing the entire dataset each time a new image becomes available, we want to process consecutive temporally overlapping subsets of the datasets. Each time a new image becomes available, it is added to the time series at the same time as the oldest image of a time series is removed, keeping the number of images used constant. One advantage of this approach is that the PS density stays at a steady level, instead of decreasing with each newly added image. Also, this approach has the potential to reduce processing time, because most of the images used in one subset have already been used in a previous subset, and therefore intermediate results can be reused. In addition to that, the dynamic development of deformation patterns can be better retraced, which I'm going to show you now on the example of the city of Patras. The city of Patras is located in Greece, on the northwestern tip of the Peloponnese Peninsula. Deformation in this area are expected due to the Gulf of Patras, which is a half-graben, active faults cutting right through the city, and subsidence in various areas of the city. In order to monitor this deformation, we are using a Sentinel-1 time series consisting of 72 images. The time series covers the period from November 2017 to February 2019. Here you can see several deformation maps of the area of the city of Patras. On the left side, you can see one deformation map created using stamps in the usual way. On the right side, you can see 13 deformation maps created using stamps with our approach. If you focus on the area in the red rectangle, you can see that in the deformation map on the left side, there is one striking deformation pattern marked in blue, while in the deformation maps on the right side, this deformation pattern changes its dimension, and also in the area a second deformation pattern is emerging. If we compare the area in the blue rectangle, you can see that in the deformation map on the left side there is no noticeable deformation pattern, while in the deformation maps on the right side there is a deformation pattern which emerges over time. The third area I want you to focus on is marked with the purple rectangle. The deformation pattern is first accelerating and then decelerating in the deformation maps on the right side, while in the deformation map on the left side there is no noticeable deformation pattern at all. The last deformation pattern I want to show you is marked with a black rectangle. In the deformation map on the left side you can see a deformation pattern close to the coastline. This deformation pattern is accelerating over time, which can be seen in the deformation maps on the right side. And here I want to finish my presentation. Thank you for your attention. Please don't hesitate to contact me if you have any comments or questions.